Let's say that a system has 4 computers, assuming that the function of each computer is independent of each other. Computer 1 works with probability 0.88, computer 2 works with probability 0.78, computer 3 with probability 0.92, and computer 4 works with probability 0.85. What's the probability that the system works only when all 4 computers operate? Okay, let's first identify some events. Let's say C1 is the event that computer 1 works. Okay, C2, computer 2 works. C3 would be the event that computer 3 works. Naturally, C4 would be the event that computer 4 works. And we know what each of these probabilities are, right? The probability of C1, it works 88% of the time, so the probability that it works is 0.88. The probability that C2 works is 0.78. The probability that C3 works, computer 3 works, the probability of event C3 is 0.92. And finally, the probability that computer 4 works, the probability of event C4 is 0.85. Okay? And so now what we want to do is say, what's the probability that the system works only when all 4 operate? So that must mean that computer 1 works, okay, event C1 occurs, and C2 occurs, and C3 occurs, and C4 occurs. Okay? Each one of them have to work for this system to operate. C1 and C2 and C3 and C4. Remember, and means intersection. So if we want this probability, and we know that these are independent of each other, then that probability is equal to the probability of C1 times the probability of C2 times the probability of C3 times the probability of C4. And we know what each one of those is. Okay, we've got 0.88 times 0.78 times 0.92 times 0.85. Whenever we work that out, we should get something that looks like 0.537. Okay? So if all of those computers have to work, what's the probability that the system works? 0.537. Okay? If you're familiar with electrical engineering, this would be a series circuit. Okay? Or if you're familiar with the reliability field, if we have a system that looks like this, where to get from here to here, it has to go through all these systems, that's a series system. Each one of these things has to work for us to start here and finish here. Okay? That's exactly what we've described here. And the probability that we can start here and end here, 0.537. This system is only going to work as designed this way roughly 50% of the time.